Okay.
Right. I was talking for the closing since you have notes here. I might look at this one for the closing.
Yeah.
Yeah.
Yeah, that works for me.
Cool.
So Noah, what's going on, man? Or they're gonna let us know when we're like
I
actually.
think we are a go. We are a go.
Beautiful.
And it's going great. I'm happy to be here. We're in sunny Florida.
Yeah.
I couldn't be happier to.
You missing New York yet?
Weather-wise, not so much. But yeah, it's. I mean, I forget what it's like to walk outside and not need a coat.
Yeah,
I could get used to it.
It's easy to get used to. It's one of those things you sleep on. Like, I lived in the Northeast my whole life, and I never thought that it would make that big of a difference in like your daily life, but I don't know. It really does.
It does. No, I'm jealous. It's got to be tough to like seeing how beautiful it is outside. You know, it just makes you want to be out there all the time.
Yeah, that part doesn't go away really. I used to get anxiety in the summer when I'd be working up in Boston or in the Northeast, and I'd be like, oh, I wish that I was outside right now because they have so many days like this, and I still feel that now, even though every day is like.
And you're close to the beach too.
Yeah, not too far.
From the beach.
Yeah, it's really nice. I'm a huge beach bum.
Yeah.
Yeah. If I could spend all day at the beach, that's like my ideal vacation, is just doing absolutely nothing on the beach.
Oh yeah, same here. Just give me like a hammock tied between two palm trees out here, and
a hammock.
Yeah.
I've always been a little heavy for hammocks, but.
All right. Let's see. We got some time here.
Yeah, got a couple minutes to go.
There you go.
So you were saying last night though that you miss some of the food in New York.
Do miss some of the food in New York. I mean, I love New York City sushi. Sushi Manhattan. Love it.
Yeah.
And what's the go-to food down here?
You
said it was Cuban?
Yeah, Cuban food. Cuban food is huge down here. There's a big Cuban population, but there's just in general in Miami, there's a huge Latin American population. So there's a lot of Colombian food, a good amount of Mexican food and stuff too. I mean, you can't go wrong with any of it.
Right.
But
you're also a master chef. I know.
I'm
one of the main things I came down here obviously to do this show, but to get some of Gian's cooking.
Yeah.
What was it? What did we have last night? The chicken, the rice. What was the veggie we had?
Bok choy.
Bok choy.
Yeah, you said that was a new one for you.
That was new for me. Yeah. That was good.
Yeah, the bok choy is pretty good. I'm definitely a fan. You gotta cook it right though. So it was crazy. We usually get the baby bok choy, which is a little bit tender, a little different to cook. And all they had is these gigantic ones. Like, I swear, it was like 12, 18 inches long, these things of bok choy.
It's got GMOs or something.
Something is in that thing. But, yeah. So we got to figure out what we're going to eat tonight for dinner. I don't know. Oh, it's going to be.
Let's see, I haven't eaten out on the town of Miami yet, so maybe we could go to a nice Miami restaurant. Anyone in the chat watching, if you have any good recommendations for eating in Miami, let us know.
Yeah.
Let's see. All right, and we got some people in the chat.
Yeah, I've learned a few good places. Oh yeah, anybody?
We got Darren.
Darren's watching. Awesome.
Yeah, I got to meet Darren this year at 3D Experience World. How's it going?
Yeah, Darren's gonna like this one, I think.
Yes, I still remember that model he made. For Model Mania.
He had an awesome.
It was kind of a blow up, almost kind of design for a carnival theme.
Yep.
It was really cool though.
Yeah, that was really cool.
Let's see, we got.
Yeah, we had a lot of good submissions for the Model Mania Cloud Challenge this year. I'm excited to see what we end up doing next year for it.
Yeah. The winner was designing that entire. It was like a cafe or restaurant.
Yeah.
And the front door was a huge violin.
Yep.
Cello.
So all music themed and everything.
Yeah, that was really cool.
Yeah, that was awesome.
All right. And Sean pointing out the X Design Hero in Gray, the limited edition.
Yeah.
So maybe we'll have to bring that one back. We could print them in a bunch of different colors too. That'd be fun.
That'd be cool.
That
would be cool.
Let's see.
So would the evil versions of these just be the opposite colors? Would it be
it could be
green
his evil
and orange
twin
or something?
Yeah, it could be his evil twin. All right, so we are good to go. Hello, everyone. Welcome back to SOLIDWORKS Live and happy Friday. I'm Noah. I'm your host today, and I'm here with master 3D designer and sculptor Gian Calise. And we're excited to talk to you today about a project we've been working on for the past few months, a really just kind of unique and fun project we got to do. It's not every day you get to design toys for work.
Right.
But we got to do that, and it highlighted just the versatility of the X apps and SolidWorks. And we also got to tie it into a great cause with a great organization in Magic Wheelchair. And on top of that, we got to give these away at 3D Experience World.
Yep.
So we got to kind of share that fun. And we won't waste any time. We'll get right into it. Doing this, we also learned a lot from a design standpoint.
We did.
Right. And you have a lot to share with us with your design process, how this idea came to be. So let's jump right in. Tell us more about it.
Sure. So let's start with kind of the inception of this project. It all began with a marketing campaign that one of our very talented marketing folks, Sarah Zuckerman, was leading the charge with what's called the xWorks campaign. And let's show that on screen right now. It's like a shot of kind of all the superheroes that are part of it. Yeah. So it was a personification of all of the X apps, or if you're not familiar, our fully cloud-based design apps like xDesign and xShape. We'll touch more on those after, but you basically turn each of them into a superhero. And it was just such a cool thing to do. Right. We had some animated cartoon episodes that had some demos mixed in, so it was really interesting. If you want to check out more from that marketing campaign, you can actually you can go to super.solidworks.com and you can watch those videos. And yeah, that was such a cool thing to be a part of. And one of our follow-ups to that was to have a SolidWorks live session. Right. And it was to introduce what's new with the X apps starring xWorks. So that's what we did. Myself and Jordan Tadich, we met with Sean on SolidWorks Live dressed as xDesign and xShape.
Love that.
And just talking about what's new with the apps. And I think Brad Williamson actually joined for that as well. It was awesome to have all of them there. And
I know Jordan, who's wearing the goggles before of xShape.
Yeah,
he took them off in this shot.
Yeah, he took them off in like the first 5 minutes. I can't blame him. It was worth it though. It was worth it to get him in those for a little bit. But yeah, it was a lot of fun being a part of that live. And what happened was after that live episode, Ian Adair, who was running it from the back end, that episode, who's actually running this one as well, he asked me, or he mentioned to me and Jordan in passing, he was like, it'd be so cool if we could make action figures of these things.
Right.
And I was like, wow, that would be so cool to do, but I have no time to do that right now. So that was back in January of last year. The summer finally rolled around. Things started to cool down a little bit, so I gave it a shot of making the first one, which is just xDesign. And we ended up, as you know, we made 2 of them. So we ended up making one for xDesign and one for xShape. And if you're not familiar, xDesign is our fully cloud-based parametric modeler versus xShape, which is our fully cloud-based subdivision modeler. So for more like swoopy, organic, free-form surfaces, whereas xDesign has got more parallels to like SolidWorks desktop.
Exactly. Those parametric commands that people are familiar with in SolidWorks, they can get all of those things in xDesign, right?
Yep.
And xShape just kind of builds on that tool set. Exactly. So looking at these pictures, when you design these action figures, you didn't have like a front, side, top view, right? This was all you had to go off designing.
Yeah.
These images. Wow. Okay.
That was it. Just images, like you see here, images of this. And then, I might peer over and like take a look at my bicep or forearm and be like, that might work. Yeah.
So you were the model for these action figures? Okay.
Well, I had they hit the weight room a little bit more than I do, but right. pretty much. But yeah, let's show some pictures of us actually making them. So this is them in progress when we were making them up in Waltham. And we got an xShape, we got an xDesign guy on the left, we got them in different phases. And here's a good shot of you and I when we actually got together to physically assemble them in Waltham on the left, and then the final version of the packaged up xDesign on the right.
You see, I got my game face on in that picture.
Oh yeah,
I'm really just focusing.
We were hard at work. I don't even think we knew that they were taking pictures. I think Sarah was just snapping a few shots, and we just
came down to the work because we made 30 of these.
Yes, 30 of these action figures.
And my fingers are still feeling it. I don't know how yours are feeling.
Yeah.
But assembling all these things together took a while.
Yeah.
And something else I like to point out when we were obviously in this picture we're together, but when it came to designing and modeling them, you were here in Miami.
Yeah.
I was in New York. we didn't really send any emails about this project back and forth or any CAD files. It was all done on the cloud.
Yep.
Because we could access our content on XDesign and xShape from anywhere, right?
Exactly. So we were both, like you said, we were both working together on the same model from totally different areas of the country, only connected by, the 3D Experience Cloud and a Zoom call here and there.
Awesome. And we were able to give these things away at 3D Experience World, right?
Yes. Okay. Yeah. So all 30 of them, or I think we made a couple extra for ourselves, but we gave away 30 of them at 3D Experience World live in Nashville, Tennessee. And we actually had a booth set up where Sarah Zuckerman was running this booth. And at the booth, you could actually enter to win them. So the giveaway was based on a challenge that you could win. And what you saw at the booth was an XDesign guy with a laptop with the XDesign model open in 3D Play. And then we had the same thing for xShape. And we would just, we had a few questions each day. And they were about like the design, the manufacturer. Like, do you remember what one of the questions was?
See, I think the design questions were something along the lines of how many features, how many sketches.
Yes.
Something like that.
Yep.
And I know the manufacturing questions were like how many layers it took to print, stuff like that.
Yeah. So anybody who was at the conference was eligible to just come on up and try to answer the questions. There were different ones for each day, and they would. If they got close enough without going over the number, then they would win. They would win one. They'd get called back to get one.
And I see we got a question here in the chat from I'm not gonna attempt to butcher the name, but were these molded or printed? These are actually fully 3D printed, and we're gonna tie that back at the end of this episode because we have a part 2 of this design series, this live design series. Part 2 is going to be about the 3D printing of them and manufacturing them. But this is about their design.
Exactly.
So. Yep.
This is their design, and so basically you could win one of these at 3D Experience World if you answered the question right. And what you'd see on the packaging, on the back of the packaging, we would actually see it's all about Magic Wheelchair, which was really the driving force behind this, because we wanted to do something really cool involved with Magic Wheelchair, since we were so inspired by the actual superheroes that do that. And what we were able to do between the small team that worked on this is we ended up giving away a big donation to the Magic Wheelchair Foundation at 3D Experience World. And there you can actually see Sarah Zuckerman, second in from the left, and Ian Adair, the tall guy in the middle, that were a huge part of this entire initiative as they hand over the check to Christine on the right, who's the wheels on Magic Wheelchair. She's the one keeping everything moving.
Right. And we've been working with them for a while, I think like 5 years.
I think so,
building that relationship. And over those 5 years, we've been able to use this software to help design those chairs and actually build them as well, right?
Right.
So I think we could see a picture of the actual wheelchair in the next slide. Is that right?
Yeah, we can take a look at I think this is either the latest one or the second latest one that the team created. So this is the Magic Wheelchair team up in Waltham, Massachusetts, at our headquarters of SolidWorks. And the kiddo from this year really loved being a princess with a castle, but she also loved cats. So her design was putting her inside a castle and having it drawn by cats. Like a cat-drawn castle.
Yeah, and that's the beautiful thing about, being able to sculpt. You could bring those cats to life, with this software. I mean, I can't even imagine designing that in Parametric,
Yeah, that would be a long time to do this in Parametric, and that's why.
And look at the results. I mean you can see the smile on her face.
Yeah, big time. And then I want to give a shout out to Rob Jost, who is, I don't think he'll admit it publicly, but he's like the inventor, or he's basically the main brains behind xShape. Of course, he has a whole team of incredibly hardworking people that are making this happen, but he is an absolute expert at xShape. He sculpted those cats, and this is him in an awesome pose with the cats there. I love this picture of him. He probably doesn't love that I'm showing this picture to the world, but
that's perfect.
But a little bit into his process was, you could see in the software on the left, like he had one body he had one sub-D for the main body and the head with the ears and everything, and then he had separate ones for each of the limbs. And then on the right, we can see how he split it up into pieces and had it 3D printed in parts to then assemble together.
Which was very similar to what we did.
Yeah.
These action figures.
Yeah.
These giveaways.
Very similar to what we did. And let's jump into that in 1 second. I think I just saw a question in the chat.
We did have a question come in. Let's see. Can 3D printers print multicolor? Great question. And we actually did do that for this project. For the heads, they were printed in multicolor on a printer called Palitra 3D, which does multicolor. But the bodies themselves are actually all designed and printed for traditional desktop extrusion machines that can only do one color. And we're going to go into a lot of detail on that in the next manufacturing episode as well. That's going to be on May 19th, but we'll plug that again at the end of the episode. But right now, again, we're on the design here, and you're going to get into the design process, right? How this even started.
Yeah, should we jump into it?
Let's do it.
All right. So I split it up into kind of 5 sub-chapters of what we ended up doing here. And the very first one was to set up a master model. So kind of all the geometry that we need in one part. And then I'm going to show how we actually got to that point. So a little bit of reverse there. But I'm going to show the sculpting of the surfaces second. And then I'm going to show how we added some parametric details to the surfaces that we ended up with. And then how we split it up into separate components and ended up with a final assembly. And then finally, the last step, I'm going to show how a design change actually propagates into the model when we wanted to change that original sub D.
Right. And there were certainly a lot in this project. A lot of back and forth changes. Even as talented as a sculptor you are, there was a lot of changes we had to go back and make.
Yeah, nothing is ever perfect. And I'm just glad that we don't have to make any more changes ever into this.
Right.
But let's start things off with the master model, setting that up.
So first off, what is master model? What does that mean?
So master modeling is a technique where basically you know that you want to end up with an assembly, but you know that the parts in that assembly you want to share a lot of the same surfaces, or basically it would be easier to model the whole thing as a part first and then split it up into separate parts to assemble it later. And that's kind of what master modeling is, or that's one way of master modeling that we're going to do here.
So before you started splitting up the arms and the legs, you designed the entire body.
Exactly.
Okay.
Exactly. And actually, before I even show it in xShape or xDesign, I'll show a little bit of it in 3D Play. So 3D Play, if you're not familiar, is a viewer totally in the cloud. So if I were to share a model with you and you didn't have access to xDesign or xShape, I could share you a link and you could do exactly what I'm doing here.
And I wouldn't have to download anything?
Nope. No download. You just got to make an account.
Perfect.
And you can do a lot of things that I'm not going to show. The main thing I'm going to show is just exploded view. So I'm going to go into an exploded view. And this is
that's so cool.
Yeah. It's awesome. And this is what they were able to do at the booth. So if you were at World and you stopped by the action figure booth, you could do this and check out what's going on in the entire assembly to help, make your guesses. So we're in an exploded view, and I just want to show while we're here kind of how the motion worked in this. And part of it is these pin connectors. So you remember putting these in like the knees.
I remember it all too well. You still feel it.
So we wanted some parts to just rotate about a pin, like the elbows and the knees, and I think the ankles too. And then some of them we wanted to swivel or revolve, like we wanted the head to be able to rotate around. We wanted kind of the arm to rotate, and we also wanted the wrists to rotate.
Right.
So
we could have taken the easy route and just made, just like a solid action figure that doesn't really move, which would have been called a figurine.
Yeah.
But we wanted to make these things fully functional.
Yes.
Which really required a lot of thought on the back end of designing.
It did. It did. And the master modeling approach definitely made this a little bit easier, though.
Yeah.
And then finally, the last type of motion we wanted was in a couple places, like in the hips and the shoulders, we wanted you to be able to both revolve it and rotate it to kind of get those 2 degrees of freedom. So we had both a dog bone and pin connector at those points, so that you could get a little bit more motion out of that. And let's actually jump out of here. So like I said, this is just 3D Play. So it's just a viewer, but I think that we can actually open this up in xShape now if you're ready.
Yeah, let's do it. So the viewer everyone has access to, and now we're in the meat of it, xShape, where you designed and sculpted this action figure. Exactly.
And here is just a view of the beginning of our master model. This is just 16 individual sub D surface bodies. And just so we're clear, when we talk about sub D, it's shorthand for subdivision or subdivision modeling. But whenever we talk about sub D or sub D body or surface, it means that we're in xShape and we're just talking about one single piece of geometry, like one single hunk of clay.
Got it.
So basically, you can think about this as we had 16 different hunks of clay that we eventually morphed into look like this.
Okay.
All right, so we got those 16, and I'm going to open up the head actually, just to show you what sub D looks like. And this is the very first thing that I made in here because it was the hardest, so I wanted to get that done first. So you can see it rolls back in the tree just like any other design in SolidWorks. Mm-hmm. And now we're in this head component, and it's pretty complicated, huh?
It is. Got a lot of vertices, a lot of edges.
A lot of vertices, mm-hmm. Yeah. A lot of stuff going on here. So this is like a compilation of a year or so worth of modeling in xShape, or at least a few months, that I got to the point where I could actually make a head. And this is not something that I would start with.
Right.
If you're new to sub D or new to modeling, we're gonna make something else today, but just want to show you how complicated we can get. And it's a slightly different environment where, you see all these edges and vertices and faces that we can just push and pull. And then when we're done with this, we can exit the sub D environment. And what it does is it takes this surface that we're looking at and it converts this into a NURBS surface. Mm-hmm. And so if you're not familiar with traditional surfacing, or you're not sure what NURBS surface means, don't worry about it. All that really means is that it is a high quality, watertight, potentially machinable surface, depending on how it's set up, that you can just do a lot more with than you can like a graphics body.
Yeah, and that came in handy for 3D printing as well. When you exported these watertight bodies, I didn't have to worry about holes in the meshes or anything like that.
Right.
Ready to send to manufacturing.
Beautiful. So let's actually get out of this now, and I'm going to show you how we actually used many sub D bodies, not even just for the head. We used obviously 16 in total, but just for the head, we had more than a couple.
It looks like you have one for the beard. It looks like I think you had a different one for the pupil and the eyebrows as well.
Yeah.
So why didn't you just model all of those in one single subdivision? Why did you split those up?
So we could have done that, actually. If we wanted to do it all in once, we definitely could have done that. The reason I didn't is because, it's really two reasons. One, you saw how complicated the head is.
Yeah.
I knew that was at a good place. Mm-hmm. I didn't want to worry about messing anything up in that. So I was like, all right, I'm just going to start with a new sub D body for the rest.
Right.
So it was really to make my life easier as a designer, not overcomplicate things. The other reason is sometimes I wouldn't want to make changes to the whole head if I just wanted to make the mustache or the goatee part a little bit more prominent.
Got it.
So it's easier.
You could edit the eyebrows by itself. You wouldn't edit his facial structure, his bone structure or anything.
Exactly.
Okay.
Exactly. So that's why we used multiple sub D bodies for just the one part. And like you said, Noah, there's 5 of them here. We ended up using I think it was the head, the eyebrow. Yeah, so the head was the first one, and then we had an eyebrow, we had the beard, the pupil, and the star. And obviously some of those got mirrored over, and then we could move on to the torso, the arms, the legs, and everything.
Got it.
So right now, this is just a bunch of bodies all in one area, and we can't really make edits to single portions of them without rolling all the way back or having to affect the rest of the model.
Right.
So one of the things that we did was we used what are called ordered geometrical sets, or OGSs for short. And all they really are, an OGS is just a string of features that are order dependent. And then you end up with either a body or multiple bodies at the end that you can do whatever you want with. And you remember using SolidWorks Desktop,
right?
Absolutely.
Yeah, you have the tree in the side. And if you edit one in the top, you have to roll all the way back.
Exactly. So just like in SolidWorks, or should I say, SolidWorks does have ordered geometrical sets. Mm-hmm. The only difference is SolidWorks only has one. In theory, it's one ordered geometrical set in each part, and that's kind of all you have there. Mm-hmm. But the difference is with XDesign and xShape and these X apps overall, we can actually have multiple. And there are a few reasons why we ended up using multiple, but I'll first just show you how we create one. So I made one for the head, and then I'm just going to grab all the sub D bodies that are a part of that head and just throw them down here. And now we have two OGSs, one that has my head and one that has all of the rest of my features.
Got it. So similar to like multi-body part modeling in SolidWorks, here you have several design trees.
Yep.
And the benefit is that you can now go into one of those design trees and edit features there without having to roll back the entire design tree.
Exactly.
Okay.
Exactly. Removing that order dependence and fast forwarding through making them for all of them, we end up with six OGSs.
Okay.
So one for the head, one for the torso, one for the arm, the fist, the leg, and the foot. So we end up with all 5 of those that you can see highlighted on the left. And the reason why we use those, just to sum this up, is first, organize and separate each portion of the model without having to jump into an assembly.
So you didn't necessarily design them in this order.
No.
You kind of organized them after the design.
Exactly.
I see.
Exactly. Because I didn't want to deal with any of this beforehand. I just wanted to, when I knew it was going to be time to make some more intense changes or add our details, we were going to have to be a little bit more organized than we were. But it removed the order dependence of features from other OGSs. So think for a second that I want to make a change to the head. I can go and manipulate anything that's going on in the head without affecting the arm or the legs or the torso. I don't even have to roll back past them or anything. It's just it's almost like they're their own totally separate part.
Gotcha.
And then finally, being able to hide, show, and reference those things separately just made it a lot easier for us to get to the point where we needed to with this design.
Right. And again, this single modeling environment, unique to the X apps, unique to xShape and xDesign, different from SolidWorks.
Right.
Okay.
So that was just about it for setting up the master model. That helped us really turn quick concepts into real products, into real models that we're able to do whatever we want with, in this case, 3D print.
Right.
But that was just about it for the master model. Do we have any questions so far?
No questions yet. I think people are just excited to get into the sculpting of this.
Yeah.
To see the real meat of this.
All right.
Yeah.
Let's do it then. Let's jump into the sculpting part. So picking up right where we left off, I'm actually going to, I faded away. I actually deleted the arm component. I deleted that arm sub-D surface, and we're going to build it totally from scratch right now. So every single time you want to use sub-D, you want to use the subdivision modeling, you start with a primitive shape or surface. And in this case, I'm going to start with just a box. All right, so I'm just dropping it in here in the model, and right off the bat, I can scale it. I can adjust the loops or edges that I have with this in a few different ways, which is really useful when you're first starting out and you're trying to figure out how you're going to make this thing. And I always recommend start with as few loops as possible. The less control points and edges that we have at the beginning, the better, and just add them as you need them.
That's good advice. And a lot of things I hear when I hear about xShape, it's like pushing and pulling a digital ball of clay. And that's really what it looks like here. It's almost kind of like therapeutic to watch, because it's so easy, it's so quick, it's so reactive. So yeah, be sure to like and subscribe to see more videos like this, because it's almost like ASMR, like really satisfying just to see someone like sculpt a face, sculpt an arm.
Oh, we haven't even scratched the surface yet. I was just about to introduce the main manipulator tool that we use to do that pushing and pulling that you were talking about. Is this tool right here that I just highlighted, and we can use this in a few different ways. So we can translate it in one direction with those arrows that just highlighted in blue. We can also translate it in just two directions, so like kind of around a plane, by using the webbing between those two arrows that just highlighted in that kind of neon green. And then if you really wanted to do it in 3 directions, then you could do it with the center point of that robot where the arrows are kind of sticking out of, that peach colored or pink. But we can also scale it with the points at the end of the arrows, or you can rotate it with the arc that kind of connects the heads of the arrows. So that's translating, rotating, scaling, and we're going to show a couple different ways. So like grabbing that webbing, I'm just moving it along that plane just in 2 directions. And then I can do a bunch of things, scaling. And I I have a few things that I'm going to need to do to this part, but I know that I'm going to need to have some type of flat face that's going to kind of be the interface between the fist and the end of the arm.
Gotcha. Okay.
So what I'm going to do here is I'm actually going to add creases. So this is going to break up the continuity of our surface here. So now we have a hard edge down there, and we basically have two, it's like we have two separate surfaces. You know, we have the flat one on the bottom, and then we have the whole rest of it that's all a continuous surface. But the rest of this is mostly just box selections and making manipulations with that robot tool that we were just talking about. So making a bunch of box selections, maybe doing a scale, maybe translating it. And this time, yeah, just scaling it down for the wrist, moving that thing over with the arrows. That's most of what this is. Inserting loops is one of the things. So editing the mesh, say we want a new loop going kind of perpendicular to the edge we just selected. So I'll click that, and now I have a new loop going in that direction. Now we can start to try to form that shoulder geometry that we see here. And another really cool thing with the creases, they don't actually always have to totally break the continuity of the surface. So that one, we wanted a hard edge that gave us a totally different surface on the bottom. But right now, we might actually want smoother creases that help us, you know, transition from one part of the surface to another without actually breaking that connection and having like an edge, a hard edge there.
Gotcha.
So we can use the slider to judge how severe we want the crease to be. And then we can also click that little checkbox at the end that just says, I want it to be a smooth transition at our crease.
And something I know you've mentioned to me before, as I go through designing and pushing, is when you learning how to manipulate that robot is really like 80% of what you do in xShape. If you really know how to scale and push and pull, that's really, you could design pretty much anything.
It's true.
You know?
It's true. There's not much you can't make, and it's almost all related to the robot. And sure, there are plenty of videos out there that Noah and I have worked on that show you the rest, but you're right. It's like 80% of it is just making selections and moving them around with the robot. But actually, I paused right here for a second because here's where we can do something a little bit different. Instead of adding a loop around the entire model, we can actually subdivide individual faces that we select. So sometimes we want more control over the entire model, so we might insert a whole loop. Here, we just want more control over just this one area, which is just our bicep area. So that's why we just subdivided that. And now, once again, we're back to just making a bunch of selections. And speaking of selections, a lot of it, I mentioned box selection, right?
You did, yeah.
So one of the really cool things, new as of like one of the last few releases, is the ability to go from a box selection to a lasso selection. There's actually a mode to turn it so that you're only making lasso selections, but I find it way more useful because I like to switch back and forth between them a lot.
Right.
So yeah, making box selections is really easy. Turning that into a window selection is incredibly useful. And now
that looks so cool.
Yeah, it's just, like I said, we're just fast forwarding through a lot of this now because we haven't introduced anything new. Mm-hmm. We're just pushing and pulling.
Same robot manipulations.
I think we might add a crease here or there, or maybe delete one, but there's not really, so we insert a loop there, we're doing some scaling. Other than that, though, there's really not much to it. Once you know how to use the robot, this is the majority of what you're going to use it for. Mm-hmm. Just doing these few different types of things here. Now, I'm still going to pause this a few times to just show us a couple things as they come up. So one example is, you'll notice that I right-clicked on the robot for a second here because sometimes, so let me actually back up for a second. When you make a selection, the directions that the arrows point in are going to be dependent on what you selected. Right. So if you select a face that's at a weird angle, and then you're going to get an arrow coming straight out of that face, and then two going kind of lateral and transverse directions.
It'll kind of have its own coordinate system.
Exactly. But sometimes you want to lock it to a certain direction. So if I only wanted to work in XYZ, I could reorient the robot and toggle it to XYZ so that only people I was looking at the chat and getting distracted. so that it only moves in the X, Y, and Z directions. So every movement will be somehow locked to our main coordinate system.
So that way you could take an edge or a point or a face that's in some type of weird angle, and you can move it in the standard X direction, the standard Y direction.
Exactly.
Gotcha.
Exactly. And then that's really most of what we used here. I mean, you can see this is from start to finish, so I'm not using anything that I haven't shown just yet. I will introduce one new thing. So one thing that you'll notice a lot is that you might get a surface part of the way there, but there are certain things that just don't look quite right. That's why whenever you're using sub-D, you got to refine. So once your model's at a certain point, what you want to do is you want to go into the cage view and refine from there. And the cage view is actually the true geometry that you're manipulating. And the surface that we've been looking at so far is really, it's interpolated surfaces from the cage that we've been setting up. So let's turn that cage view on. So you can see here, it's a bunch of faces. They all have, for the most part, 4 points, and you can still edit the points, the vertices, the edges, or the faces. And my general rule of thumb is if you can make it look kind of how you want it to look in real life from the cage view, then it's going to look perfect in the surface. But if things look out of whack in the cage view, like you'll see here, it looks a little too square at the base of our forearm there, or it just didn't look quite as organic as we wanted it to. So if we make it look a little bit more organic from here in the cage view, it's going to look even better in the surface view. And there are other benefits to using the cage view, but that's the main one I wanted to talk about. All right, so just wanted to show again, a line by line is another tool that we use, and this is great for making flat faces. Mm-hmm. So I want to make sure that the face that's going to interface with the fist component, with the hand, is going to be perfectly flat. But I might want to adjust that a little bit. So it actually gives me a line with a couple different, a couple manipulators, so I can adjust the endpoints or the entire line and make sure that they're nice and flat.
And that came in handy with manufacturing too, because those flat faces, they were printed on those flat faces.
Exactly.
So that was also a really useful feature from the design phase that came in handy later on.
Yeah, that was very big to be able to do that. So I just want to show it. So this is the original sub-D body that we started with before we did any manipulation. And now I'm going to show before and after. So watch carefully as I fade from one to the other. And you might notice too that it looks like xDesign might have been hitting the weight room a little bit. He upped the curls in that time.
Right.
But the rest of it...
quick pump.
Yeah. Exactly, yeah. He got a quick bump. So one last tool that I want to show for
this is a cool one though.
Sub-D. Yeah, this is I think this has become my favorite one. It's called soft selection.
And this is a newer one, right? In the last few releases?
Yeah, this is new as of, I want to say January or February was just added.
Yeah.
So it's called soft selection, and what it allows you to do is extend the influence of your selection outside of what you actually selected, but in a very strategic way. So let me show you what I mean. So I launched soft selection, and I can either do it by distance or by faces. So now whatever I select is going to, you'll see that it actually highlighted a bunch of other vertices out here that are now also being affected. It highlighted them in different colors. So the colors represent the amount of influence. So the red color means that they are going to be influenced either 100% or close to 100%. And the colder the color gets, the closer it gets to purple, blue, means that it's not really being highly influenced. So if I scale out if I take this slider and I go out to the right, I can extend the influence further, let's say up to 7 faces away. And now when I make a movement, it's moving almost the entire arm.
Gotcha.
And this made this was a big help, like when I mentioned before, when we changed the knees, when we made the whole legs different. I don't think I would have been able to do it without it. Or if I did, it would have just taken a lot more time.
Right. And I love the different colors too, that visual feedback. You could clearly see what faces you're editing very quickly and really responsive too. So seeing how that arm was designed, obviously you make it look very easy, but to a lot of people who are used to parametric modeling, SOLIDWORKS modeling, this is very new to them. It can kind of be intimidating. What's like the transition like from parametric to this sub-D? Like how long does this take you?
So I would say that, so for just the arm, I could definitely do that. If I had no reference or anything, I could definitely do it in the afternoon. This particular one, I'd modeled it a couple times because I had to model it again for this video. So this one was actually, I want to say it was maybe 40 minutes to get to this.
So under an hour to get that,
to get the arm,
lifelike looking shape.
Yeah, it's fast, man. Once you get really good, like you've been saying, the robot is so much of it. If you feel comfortable with the robot and some of these basic tools we're talking about, you can really crank out a lot of crazy shapes in not a lot of time at all.
Awesome.
But yeah, I don't know how long this entire thing would have taken. The head was definitely took the longest.
Definitely.
But you'd be surprised. The rest of like the torso, the arms and the legs, getting them to look real and like lifelike. I would say if we had to start, if I had to model this whole thing again, like the head, the torso, the arms and legs from start to finish, I bet I could do it in under a week if I really had to. Yeah.
Wow. Yeah, that's fast.
Still takes time, obviously, but
and of course there's revisions and changes you got to go back to, but just to get the basic humanoid shape.
Yeah, I like that. The humanoid shape.
Yeah, I know. Shout out to Sean. He's in the chat. He loves that word, the humanoid shape. But yeah, so under a week to get that shape. Wow, that's awesome.
But yeah, so that's about it for sculpting the surfaces in Sub D. So fast freeform modeling that you can get really complicated shapes in not a lot of time, especially if you're used to traditional surface modeling. I'm sure it probably would have taken more than 40 minutes to design to get that arm. It probably would have been 40 sketches alone, which would each take, I'd say, a minute or so. So
and bringing it back now to more of those traditional designers that are used to SolidWorks, used to those parametric modeling tools, you had a lot of those in this model as well, right? It wasn't all just sculpting.
Yes. Yep. It was not all just sculpting. That was just the beginning. And then we had to, we had to make it functional, which was a lot more your domain of actually getting this thing to be 3D printable and to work. So remember, we're going to show it at the end, but there is going to be a part 2 to this where Noah's going to do a deep dive into the 3D printing and manufacturing side of this.
Right.
Let's talk about these parametric details. So there's not a ton to show here. A lot of it was just splitting bodies. So like here, I'm using just a split body command with a couple setup sketches. I'm going to use this a couple times just to, I first need to get an elbow portion. And then the other thing that I need to do is I want to split that elbow into 3 pieces. And I also want to split the upper arm into 2. Because really I just want to end up with 3 parts at the end. I want the shoulder, I want the upper arm, which is like the bicep tricep, and then I want the forearm. So I split these up. Now I'm going to combine the ones that I want, because obviously I just said I need 3, but I have 6 bodies here, if you count them, the bodies in the arm at least. So I'm going to combine these bodies. I'll first do, let's do the upper arm with the outer portions of the elbow. Okay, so that gives me our upper arm body, and then I'm going to do the same thing for the forearm and get that midsection of the elbow. And then after that, we have a few more parametric details to add. Like I think we're going to punch a hole through this where our elbow pin is going to go. Yep, we'll cut through all. I didn't even have to open the dialog box actually, which is really nice. Just do an extrude cut right through that. And I'm going to do that again.
So this is like that master modeling technique you mentioned before, right? You modeled the whole arm.
Yep.
And now you're splitting it up into different components.
Exactly.
Very cool.
And you might actually notice that we're actually in XDesign now, and because I just added an extrude cut, now I actually just jumped into another extrude. But because we have a super feature, you can actually switch from extrude to revolve to sweep. So I'm going to change that to revolve, and then I'm actually going to just grab that one line as my center of or my axis of rotation or revolution. So now we get that spherical geometry where our shoulder is going to connect up with the torso.
Right. And I think I even got ahead of myself. Using these parametric features, you never even left xShape, right?
Yeah.
So you have the sculpting xShape, and you have the parametric features that you're used to in SolidWorks, but because you have XDesign and xShape, you have all the features you need in one window. It's not like you have to switch back and forth between 2 apps, right?
Exactly. Yeah. And so if you have both tools, XDesign and xShape, just like you said, Noah, you can access both from xShape. I'm still in xShape right now, but I just have all my XDesign commands right there, so I never have to switch.
That's so useful.
So let's fast forward through more of these parametric details. So I fast forwarded through, like you might see, I did something to the hips, and I got the belt in there, and now I'm just using some of the cool AI built into xDesign to add those fillets, picking up similar edges. But this is really what I wanted to end up with. I'm going to do a section view just to show you what we end up with exactly, at least for our arm. So I fast forwarded through parametric details for like really everything, but for just our arm, we ended up with 3 arm bodies: the shoulder, the upper arm, and the forearm. And then we also have 2 connectors in there. We have the dog bone connector connecting the upper arm to the shoulder, and then we also have a pin connecting the upper arm to the forearm, giving us that elbow joint. So that was really that was the end of this portion of just getting those mates and everything getting everything set up so that we can add mates after the fact. But really, this was just focused on the geometry. Our geometry is done. Our master model is complete. Remember, this is all in one physical product. So right now it's just a part. And that was all the parametric details we needed to add.
Wow. So definitely most of the work in this was getting that sculpting right, getting the proportions right of his arms, his knees and stuff like that. Yeah, adding the pins, I remember when we were going through it, once we added one to the elbow, it was very similar to the knee.
Right.
And once we made the shoulder, it was the same thing for his hip.
Exactly.
So we were able to repeat a lot of that process to make him like fully movable.
Right. Yeah, and it just worked out really well, and it was super helpful that you were able to, while I was doing the sculpting, you were testing out some of the joint mechanisms.
Right, exactly.
And you'll see more of that if you tune in for part 2, but it was an awesome workflow that we were able to do and really tackle this together.
Definitely a divide and conquer approach.
So our master model is complete. We finished adding our parametric details. We were able to add functional elements without changing environments. Now let's go and split this whole thing into individual components now. So again, we're in one part, we're in our master model. We want to make components. The first thing I actually need to do is turn on external references so that our master model actually updates our components. So if we make changes, they're always going to be in the master model, and our components will always be linked to that master model.
Okay.
So external references is on, and then I'm going to use the make component button. That command allows us to take, it could actually be bodies, or it could be a list of features that you can make into their own component. In this case, I'm just going to use bodies. So I'm going to grab the upper portion of the shoulder, so just the shoulder. I'm going to call that shoulder, making it as a linked body. And now I have a new component called shoulder, which is linked to the shoulder body, which, if you remember, we have 3 bodies in our arm OGS. We have the shoulder, the upper arm, and the forearm that are all in the arm OGS, and that is our master model. Our master model is all those OGSs together.
Got it.
But now we have it linked to linking out to our physical product for the shoulder. Now I just repeated that for the rest of the portions of the arm.
So just to make sure I'm getting it, you design the arm, and in its own OGS.
Yep.
And then you split it up into components.
Yep.
But it's still in the same OGS.
Still in the same OGS.
So then you took that shoulder out into its own physical product.
Yep.
But you still linked it. So if you go back into the arm OGS and make any changes, that shoulder physical product is automatically going to update.
Exactly. So like Noah just said, just to reiterate, and this is all due to the single modeling environment. So everything in xDesign is not a part or an assembly, it's a physical product. And a physical product can either be a part or an assembly, or in this case, it can actually be both. And here's what I mean by that. The physical product that we started designing our master model is the very one at the top called the xDesign action figure final. Okay, and that's also acting as an assembly right now. Okay, so that physical product contains this master model geometry in what's called its 3D shape. So all those OGSs, they're all stored in the 3D shape, and that's kind of like the geometry portion of the physical product. The other portion of the physical product is activated. It becomes an assembly once you have components within it.
Right. So once you made that shoulder component its own physical product, this whole action figure model became both a part and an assembly.
Exactly. And that's all due to the single modeling environment here that allows us anything to be a part or an assembly or both.
Gotcha.
So what I'm actually going to do now is I'm going to hide some portions of our master model so that we can see the difference in, so that we can actually focus on the components that we created from them. So I'm hiding these parts. The only thing I'm going to leave is the torso. So if I select that 3D shape that contains all of our OGSs, you'll see this is what's shown right now from our master model. This is the only part that's left shown. The arm itself that you still see there are the components that we just made. So those 5 components are what we just created. And now we can actually add some mates because they are their own components. So I'm just going to add a few here. I'm going to do a concentric between the upper arm and the shoulder, and then I'm also going to make that coincident, those 2 flat faces. And really that's all we need. We're just going to add a few more concentric and a few more coincident.
The same type of mates from SOLIDWORKS?
Yep, okay. Same types of mates. And they pop up just when you just when you start selecting faces. And I'm going to fast forwarding through adding all those other mates. Let's actually test out the motion. Oh, I also changed the colors of the components so we can see them more easily. So
that is so cool.
Yeah,
that shows so nicely. And I remember this was especially useful when it came to manufacturing because without having to spend any resources in printing, we already knew how much this was going to move, or we had a general idea of how much it was going to move.
Right.
So yeah, really useful there.
So we've got all that split into components. Our components are red, but our master model is still gray, just for keeping it easy to follow along here. We have mates for our arms. What I actually want to do, before I finish this whole assembly off and make everything its own component, what I actually want to do is make changes to the master model. So we finished splitting it into components so that we can understand the motion and the efficacy of our assembly. Now we're going to change the master model, which we did a number of times.
We did. A lot of revisions.
Yes.
Back.
A lot of changes. Most of it is due to our perfectionism, probably.
Right, yeah.
So all self-imposed stress, but...
Right. Yeah, once we started it, we had to go all the way.
Yeah,
there's once the head moved, the shoulder had to move.
Oh,
once that moved, his elbow had to move. So yeah, we definitely took it all the way.
But let's show what that actually looked like.
Yeah.
So changing the master model, jumping right back to where we just were, I'm going to hide these components, okay? And I'm going to show the arm again for my master model. So once again, we're all gray. We're just showing our master model now. And I want to make a change to it, to our original sub D body for that. So I'm going to go into that sub D for the arm. And yeah, this guy, he's been slacking on biceps a little bit. He's been doing too much shoulders. So we're making his deltoids a little bit bigger. And he's been skimping on the curls. So we're actually going to make his bicep a little bit smaller.
What'd you say? He eats iron for breakfast?
This guy
just tough guy.
He eats weights, but he's been slacking on the curls right now. So been too much shoulder lifts or whatever. So we made some changes to the sub D driving this. Our master model has now been updated. Okay. So now what I'm going to do is I'm going to hide this. I'm going to collapse that. I'm going to show our components overlaid on our master model, and see how they're kind of there's like gray, red overlapping areas.
Yeah.
So that's where the model is actually perfectly superimposed and perfectly overlapping, is where you see a lot of that interference or the overlap.
That's the master model and the physical products, right? That are superimposed on each other.
Overlapping with each other. But the 2 points that we just edited, the bicep and the shoulder, they don't have overlap. And the reason is because now our master model is bigger in the shoulder area, so it's actually popping through the physical product. Mm-hmm. And our bicep we made smaller, so now we only see the physical product left, the red part, and because the bicep in our master model has been made smaller and is now behind that surface. So I just wanted to show this so that you could see what is going to change, and watch carefully as I'm about to now just go down to solve this thing. So by solving this assembly, now you'll see we have perfect overlap once again.
Gotcha.
And now our components are now up to date with our master model.
And that's because you had external references turned on when you made those new components, right? So it would always look back to that master model.
Exactly. If we didn't have external references on, then it would have just been like a copy of the body or of the part at just that one point in time, and there would have been no link. So we would have been just kind of stuck with what we had. But now we have the master model that has all the geometry we actually work on, and that actually drives everything in our components.
Gotcha. I know you mentioned we're perfectionists. If you had to guess how many times we went back, or how many times you went back when you were sculpting this?
At least a dozen, or maybe a couple dozen times that we would go back, and whether it was a small change or a big change, I think did I mention already how we moved the whole knee up a little bit?
Yeah, we moved the knee up. We moved. I think we made his torso.
Yeah, his torso had to get smaller, and actually I think shorter. I think it was too long at first. And that's why probably would have helped to have some type of reference in here, but it was a challenge. I was trying to challenge myself here and see what we could do. But that's our components up to date now. We can hide that original part of our master model and just see our parts are up to date, our physical products, and we can replicate this process for all of the other components. So that the master model contains all the geometry. The assembly has all of our other parts in it that are driven by that, and by having it all mated up, we can test out the motion, like we were saying, for the assembly, and we can also test out some different poses for this guy.
Love that. So cool. All that's missing now is a simulation we could run on him, see how fast he can run, how much he could lift.
Yeah.
So let us know in the chat if you'd like to see any cool simulations with the X Design or xShape action figures. That'd be cool.
We would love to do that. But that was making the change to our master model. So quick changes there in our master model, drive changes in the assembly. So giving us that single point of, I want to say single point of truth, but that single point, our master model being the only place that we have to go to actually make edits to the geometry. And then, anything with mates is all within the assembly. But that's just about it. So just to recap, we set up a master model. We used OGSs so that we could organize it and work on it efficiently. And then I showed how we sculpted some of the surfaces by just doing that whole arm from start to finish. We added some parametric details, punched a few holes through it, did a few revolves. Then we split it into individual components so we could understand the motion of that assembly. And then we finally made some changes to our master model, showed how those changes propagate into our assembly, and then we fast forwarded to the end where we had replicated all those steps and finally have like a complete master model and working assembly of this action figure.
Awesome. Looks so cool. And the product came out so great, I'd say.
And we did this not just for X Design too.
We did this for xShape as well.
Yep.
Yeah, he's on the desk as well.
Yep.
And I almost think he was kind of a bit simpler too, because X Design, he had like those pockets, he had the knee pads.
Yep.
And his logo had different colors too, so we had to incorporate different parts. So I would say xShape was in a way almost easier, right? Yeah,
xShape was definitely easier, and not even just because of that, but we were also able to make xShape. We just made a copy of the X Design guy. And I just made him a little bit less muscular, a little bit less.
Just took him out of the gym.
Yeah.
But his hair too, I thought that was really cool because, you could do a lot with subdivision.
Yeah.
But obviously sculpting hair, thin features, those would have been impossible to manufacture.
Yes.
So you had to really keep manufacturing in mind when you sculpted the hair of, say, xShape, right?
Yeah, I did. And I mean, you saw the result. It's obviously it doesn't look like perfect hair. It's not like we just put a wig on the guy, but
it's action figure worthy.
Exactly. It looks like plastic hair. I mean, he's got kind of a weird hairstyle. It looks like he just went through a wind tunnel or something.
Right.
Or he's just using way too much product.
But no, they look great. And let's see, we're actually at the top of the hour. So again, these are our two core apps: X Design with Parametric, xShape with subdivision modeling. And if you guys want these models, they're available to you right now for free. You go to solidworks.com/actionfigure-model, and there you could get the 3D XML, which has all these subdivisions that you sculpted.
Yep.
So you can mess around with those and have some fun. You could make him look like he hit the gym even more, make him even bigger. Or you could go to solidworks.com/actionfigureSTL, and you could actually download the STLs that are ready to go on a 3D printer. You can fire those up right away. And on top of it, we had a big impact too with Magic Wheelchair, right?
Yes, we did. We had a huge impact. I mean, that was amazing to be a part of.
Yeah, that was really cool. So and then really came full circle with that.
And for people who want to try out these apps, but maybe are not ready to use it professionally yet, they have options with 3D Experience SolidWorks for Makers, right?
Yes.
So if you're not familiar, 3D Experience SolidWorks for Makers comes with 3D Experience SolidWorks as well as XDesign and xShape. And you can see right on here, this is a screenshot from the website this morning. You can buy it for $9.99 a month or $99 a year. Obviously, it's restricted so that you can't use it professionally. But if you want to just model some cool things, or if you're a maker at home, like this is an awesome. I own a license of Makers myself, so I can have some stuff that's actually just mine and not owned by SolidWorks.
Right. So for $9.99, someone could have access to all the tools and features and commands that you use to design this action figure.
All of those plus 3D Experience SolidWorks.
Yeah.
So if you wanted to, instead of using XDesign and xShape together, you could have used SolidWorks and xShape together. So you know how we kept adding parametric features? You could have just brought that into SolidWorks instead, but I'm just so used to the cloud environment now, I decided to stick with XDesign.
Perfect. Yeah, and also, we got to drive home. We'll be back. We'll be back talking about these action figures for part 2. I was happy to see we got some great manufacturing questions in the chat. We're going to cover all of those and a bunch more. That's going to be on May 19th. We're going to talk about how these figures were printed, what print settings, how they were printed with absolutely no support. So a lot of cool tips and tricks we'll share. And yeah, we'll both be back for that. You'll be back for that one too.
Oh yeah.
And we also have another live design coming up. Let's see, on April 4th. So we have
some manufacturing live.
Yeah, it's another manufacturing lives. Next Tuesday, it's going to be featuring David McBriar and guest NC Kishore. And they'll be talking about NC's journey throughout his manufacturing career and how he made his way through the ranks of Dassault to lead the Delmi fabrication team. So that's going to be really cool, 11 a.m. Eastern on April 4th. So make sure to tune into that one as well. And let's see. Of course, like and subscribe to see more content like this.
Yes.
So we can see more of these satisfying sculpting projects. And let's see, is there anything else?
I think that's it. I think we'll see you next time.
We'll see you next time. Thanks, everyone, for tuning in. Be sure to like and subscribe to get notifications for those future episodes. Thanks, everyone.